This is AQA Coordinated Science, it's Chemistry Higher Paper 2, and this is question 3. And we've got here a question which relates to dissolving solids in 5 cm cubed samples of water, and we've got lots of data in this table. Now, the first thing that you've got to do is calculate mass X in table 2. So we know how much we've got in 5 cm cubed. We've got 0.08 grams. If I know what I've got in 5 cm cubed, I can divide that by 5, multiply it by 1,000, and that tells me how much I would have in 1,000 cm cubed. We'd have 16 grams. And you can actually see the same pattern has taken place with the seawater just above, which has gone from 0.14 up to 28. It's essentially gone up by a factor of 200. On to the mechanics of the practical, I suppose. We've got a 5 cm cubed volume of water. What's an advantage and what's a disadvantage of using a larger volume of water? Well, 5 cm cubed, if you don't measure it absolutely perfectly, or even if you do measure it perfectly with the apparatus at your disposal, there is scope for there to be greater margin of error. So a larger volume will give a more accurate result. But if you do use a larger volume of water, it's going to take longer and it does require more energy to heat the water. Moving on to 3.3, potable water is not pure water. Describe the difference between potable water and pure water. Well, pure water is just H2O. It has absolutely nothing dissolved in it. Whereas potable water does have dissolved solids. The big pitfall that you want to avoid on this question is to say that potable water is fit to drink. That's true, but both of them are safe to drink, so it's not considered a difference. Moving on to 3.4, potable water is obtained from both groundwater and seawater. Describe how they're treated to produce potable water. So this takes you back to probably flowcharts that you've seen, and we don't need to go into huge amounts of detail. But if you think about water going from a reservoir, we filter it, then we sterilise it, and at that point it's fit to drink. There's an extra thing that we need to consider with seawater. Seawater might not need that same level of filtering and sterilisation, but it does need the salt removed because otherwise it's not drinkable. So desalination or distillation gets to the point that we can drink it, making the seawater potable. And another little calculation here, percentage by mass of dissolved solids in a 6.5 gram sample is 2.2%. So we want to know what is 2.2% of 6.5 grams. So we do our little calculation and we get to 0.143 grams.